Radio frequency interference, or RFI, in ballasts and light fixtures can be a complex issue. Let's break down some key aspects and resources for understanding and mitigating it. Firstly, it's essential to understand the basics of electromagnetic interference, or ME, and RFI in fluorescent lighting. Electronic ballasts, which are commonly used in fluorescent and LED lighting systems, can be a source of RFI. This interference can disrupt radio communications, electronic devices, and other sensitive equipment. Secondly, a critical area is RFI troubleshooting specifically related to ballasts and rectifiers. Diagnosing the source of RFI is the first step towards implementing effective solutions. Factors contributing to RFI include the design of the ballast, the quality of components, and the installation practices. Understanding the causes of RFI is fundamental to preventing and resolving issues. RFI can stem from various sources, including the switching circuitry within the ballast and the interaction of the ballast with the power supply. Next, examine the RF immunity of fluorescent ballasts and light fixtures. Immunity refers to the ability of a device to withstand interference without malfunctioning. Improving the RF immunity of lighting systems can reduce the likelihood of RFI-related problems. Electromagnetic compatibility, or EMC, is a crucial consideration in lighting systems. EMC refers to the ability of equipment to function satisfactorily in its electromagnetic environment without introducing intolerable electromagnetic disturbances to other equipment in the environment. Thirdly, it's worth noting mitigation techniques for electronic ballasts. These techniques aim to reduce the RFI emissions from the ballast itself. Shielding, filtering, and proper grounding are commonly employed methods. Now, let's discuss some additional resources. IEEE STDC 62.41 provides recommended practices for surge voltages in low-voltage AC power circuits. Surge protection is essential for protecting electronic ballasts and other lighting components from damage caused by voltage transients. The National Electrical Manufacturers Association, or NEMA, lighting section offers a wealth of information on lighting standards, regulations, and best practices. Their resources can be invaluable for staying up to date on the latest developments in the lighting industry. A deeper dive into fluorescent lighting reveals that the rapid switching of current in electronic ballast generates electromagnetic radiation. This radiation can propagate through the air or along power lines, causing interference with other electronic devices. Understanding the frequency spectrum of RFI is also crucial. Different types of ballast and lighting systems may emit RFI at different frequencies. Identifying the frequency range of the interference can help in selecting appropriate mitigation techniques. Filtering is a common method for reducing RFI emissions. Filters are designed to block or attenuate signals at specific frequencies. Installing filters at the input or output of the ballast can significantly reduce RFI levels. Shielding involves enclosing the ballast or lighting fixture in a conductive material that blocks electromagnetic radiation. Shielding can be particularly effective in reducing RFI emissions from the source. Grounding is another essential aspect of RFI mitigation. Proper grounding provides a low impedance path for unwanted currents, reducing the likelihood of RFI. It is important to ensure that all lighting components are properly grounded according to electrical codes. In addition to these techniques, careful installation practices can also help to minimize RFI. Avoid running power cables for lighting systems near sensitive electronic equipment. Use shielded cables and connectors where appropriate. Keep cable runs as short as possible to reduce the antenna effect. Regular maintenance of lighting systems can also help to prevent RFI problems. Check for loose connections, damaged components, and signs of corrosion. Replace any worn or defective parts promptly. When selecting lighting equipment, choose products that are certified to meet relevant EMC standards. These standards specify limits on RFI emissions and requirements for RF immunity. Working with a qualified electrical contractor can also help to ensure that lighting systems are installed and maintained properly. A contractor can assess the potential for RFI problems and recommend appropriate solutions. Furthermore, consider the type of ballast being used. Different types of ballasts, such as magnetic and electronic ballasts, have different RFI characteristics. Electronic ballasts generally produce more RFI than magnetic ballasts. However, electronic ballasts are also more energy efficient and offer better control over lighting levels. When using electronic ballasts, choose models that are designed to minimize RFI emissions. Look for ballasts that incorporate filtering and shielding features. In addition to the ballast itself, the lighting fixture can also contribute to RFI. The fixture can act as an antenna, radiating RFI from the ballast. Choose fixtures that are designed to minimize RFI emissions. These fixtures may incorporate shielding and grounding features. The location of the lighting fixture can also affect RFI levels. Avoid placing lighting fixtures near sensitive electronic equipment. If possible, locate lighting fixtures in areas where RFI is less likely to cause problems. Another factor to consider is the power supply voltage. Higher voltage power supplies tend to produce more RFI. If possible, use lower voltage power supplies to reduce RFI levels. The type of lamp used in a lighting fixture can also affect RFI emissions. Some lamps, such as compact fluorescent lamps, or CFLs, tend to produce more RFI than others. When using CFL, choose models that are designed to minimize RFI emissions. Dimmers can also be a source of RFI. Dimmers control the light output by varying the voltage applied to the lamp. This process can generate RFI. When using dimmers, choose models that are designed to minimize RFI emissions. Surge protectors are also essential for protecting lighting systems from voltage transients. Voltage transients can damage electronic ballasts and other lighting components. Surge protectors can help to prevent this damage. When selecting surge protectors, choose models that are designed to protect against both common mode and differential mode surges. Common mode surges are voltage spikes that occur between the power lines and ground. Differential mode surges are voltage spikes that occur between the power lines. In addition to surge protectors, line filters can also be used to reduce RFI. Line filters are designed to block or attenuate RFI signals that are present in the power lines. When selecting line filters, choose models that are designed to filter out the specific frequencies of RFI that are being emitted by the lighting system. Furthermore, consider the use of fiber optic lighting systems. Fiber optic lighting systems use optical fibers to transmit light from a light source to the point of illumination. These systems do not generate RFI because they do not use electricity to transmit light. Finally, keep in mind that RFI problems can be complex and may require the assistance of a qualified professional. An electrical engineer or EMC specialist can help to identify the source of RFI and recommend appropriate solutions. They can also perform RFI testing to verify the effectiveness of mitigation techniques. Remember to consult the National Electrical Code, or NEC, for guidance on safe and effective wiring practices. The NEC provides requirements for grounding, bonding, and overcurrent protection, all of which are important for minimizing RFI. Understanding the NEC requirements for lighting systems can help to prevent RFI problems and ensure the safety of electrical installations. Specifically, Article 410 of the NEC covers the requirements for luminaires, lamp holders, and lamps. This article provides guidance on the installation and wiring of lighting systems. Article 250 of the NEC covers the requirements for grounding and bonding. This article provides guidance on the proper grounding and bonding of electrical equipment, including lighting systems. In addition to the NEC, other standards and regulations may apply to lighting systems. These standards may specify limits on RFI emissions and requirements for RF immunity. It is important to be aware of these standards and regulations and to ensure that lighting systems comply with them. Also, remember to consider the impact of lighting systems on other electronic equipment in the vicinity. Ensure that lighting systems do not interfere with the operation of sensitive electronic devices. If necessary, implement mitigation techniques to reduce RFI levels. Regularly inspect lighting systems for signs of damage or wear. Replace any damaged or worn components promptly. This will help to prevent RFI problems and ensure the safe and reliable operation of lighting systems. Finally, remember that RFI is a complex issue with many potential causes and solutions. By understanding the principles of RFI and implementing appropriate mitigation techniques, you can minimize the risk of RFI problems and ensure the proper operation of electronic equipment. Remember to consult with qualified professionals when necessary and to follow all applicable codes and standards. With a proactive approach to RFI management, you can create a safe and efficient electromagnetic environment.